These are some quick notes to go over the steps to solving equations when you have variables on both sides. So when we're strategically solving and we want to know the value of an unknown variable, solving is kind of dictated, and we can see that by an equal sign. Remember that when we don't have an equal sign, we're just simplifying and finding an equivalent expression. But when we have an equal sign, we are solving for something. And in this case, we don't know what the value of x is. So we have some unknown values. We know that the x in this equation is going to have the same value. This x on the right side cannot be a different value from the x on the left side. So it's kind of like having the x's split out in different places. We've got to first get them all together before we can solve for them. So our first step is to eliminate the parentheses if we have one. So we always look. So I'm going to rewrite here our problem, and we're first going to eliminate the parentheses. So when we do that, we're distributing. Remember, 3 times x is 3x. 3 times a positive 1 is a 3. And we rewrite everything else. Now, before we start moving things left and right, we need to combine all the like terms on each side. So as we move over into combining like terms, we're going to look to the side to the left, and we can see 3x plus 3. Well, those are two terms, but they're not alike, so we can't combine them together. So there's nothing that can be done there. On the other side, when we look, we have the constant, and we have an x, and we have a negative x. We have 2x and a negative x, so we can combine those. So when we do that, we can think about putting a little wall down the middle of our equals to keep things separate. Whatever we do to one side, we have to keep things balanced to the other when we start moving things. Right now, we're just combining. We're just kind of making it a little neater. So this left side can't be changed because they're not like terms, but the 2x and the negative x can be combined, and we have a 1x. Now we can write a 1, putting a little dot, but it's not necessary. We know that if we just have an x staying alone, it just means 1. And then our 24 can't be combined, so it just stays there. So now we've simplified this down to 3x plus 3 equals x plus 24. Now our next step is we have to isolate the variable. Isolate means to get alone. So we want to isolate and get it alone. Well, I have 1 over here, and I have 3 x's over here. So I need to get them to the same side. You can choose which side you want to move variables to and the numbers to. One's going to be on one side, one's the other. It doesn't matter. I like to do what's simpler. But if you're having trouble with solving equations, if you just pick a side and always do that side, then you know you won't forget kind of what you're doing. So let's say I'm going to put my variables on this side here, and maybe my numbers over here, so I can think about that when I do it. Okay, so let me clear off my spot here. So I'm going to do the inverse operation in order to get those over. Because this is a positive x on this right side, I'm going to subtract x and subtract x. I can only do that with things that are alike. I couldn't put the subtract x under 3 because they're not like terms. So when I subtract, I have a positive x and negative x over here, and they're gone from that side. So the only thing that is left on this side is the 24. Here I have a 3x minus x, so I have a 2x, and then I have to bring down the plus 3. Okay, so now I've simplified by isolating the variable to one side. 2x plus 3 equals 24. So that's my next step. Now I want to eliminate the constant. I want to move the constant away to the other side. So I want to get the numbers on the side by themselves. So to do that, I'm going to subtract 3, because right now it's a positive 3, from both sides. When I subtract 3 from a positive 3, they're gone, and all that's left here is a 2x. And 24 minus 3 gives me a 21. Now, what I'm left with here is saying 2x is equal to 21. That means 2 times whatever the value of x is gets me 21. So I need to now find out what that x is worth by eliminating the coefficient. Remember, coefficient is the number beside your variable. So to do that, this 2 times x is being multiplied. So to undo multiplication, I divide. I divide by whatever my coefficient is. So I'm dividing by 2. Dividing by 2. 2 divided by 2 is 1. So I'm left with just 1x. And 21 divided by 2 is what I'm left with. Now, this is not a whole number solution. This is a fraction. We know that 2 can't go into 21 evenly. We would get a decimal. So we can leave it as an improper fraction. Now, the thing that we have to do to make sure that this is actually right is I'm going to check my solution. This is very important because if we don't check our solution, we've done all this work, we could have made one little mistake and we'll be wrong just because we refuse to check just one little quick thing. So I'm going to go up to my problem. This is my problem that I had originally. So I'm going to make a copy. And we are going to then plug in to our original problem and see if we're right. So we have 21 halves as x. So everywhere I see x in my problem, I'm going to plug it in. So we have 3 times 21 halves plus 1 equals 2 times 21 halves plus 24 minus 21 halves. Now, you can use a calculator for this just as easily and plug it in to prove that it actually works. So when you plug it in your calculator, you want to use exactly the way it's written, but we're going to do it kind of quickly together. So when I think about 21 halves plus 1, and when I add fractions, I have to have like denominators. We can rewrite 1 over 1 is still 1. Well, these aren't like denominators. I'd have to have this be 2. So I'm saying 21 halves plus, if I change the denominator to 2, I end up with 2 over 2. Same thing. It still simplifies down to 1. So when I add these together, I end up with 23, because I add straight across 21 plus 2, and I keep the denominator. And I'm going to multiply that by 3. So when I multiply that by 3, I'm just multiplying straight across the top. 3 times 23 gives me 69 over 2. Okay? So that side's been simplified. Now I can go to the other side. 21 times 2 gives me 42 halves. I'm going to leave it like that. And then plus 24 minus 21 halves. Now, I want to combine all of these things together, and so they all have to have like denominators. I can start with my fractions first, and I can also simplify this down if I want. But when I put this in my calculator or add it all together, I end up with 69 halves. And because these have to be equal, because it's an equation, and it's 69 halves here and 69 halves here, I know that my x value is correct. So my solution to this equation would be x is equal to 21 halves.